Good afternoon, everybody. It's time for Wisdom Wednesday. Wondering if you've ever thought about what it is that really causes us to age. We know now that actually this is a diagnosis that is aging, actually. I mean, why is it that some days we wake up and we can barely get out of bed, and other days we jump right up and can get moving? Or why is it that we look around and someone our age looks 5 or 10 years younger, and yet there are other people our age that look 5 or 10 years older? What is it about this passage of time, this time-dependent type of functional decline that affects us, and is there something we can do about it? Now, a couple of weeks ago, I talked to you a little bit about the hallmarks of aging. So I thought we could march through some of these in the next few weeks and just touch base on perhaps what they are, and then of course ways that we can try to mitigate the issues of these particular hallmarks that have to do with this decline of function over time. So the first one we mentioned was genetic instability. So what exactly is that? Well, we know that our genetics are programmed in the DNA in our cells, in the nucleus of our cells, but also the DNA in our mitochondria, which are those little energy sources within the cell. And what it is that happens with our DNA is that when we create new cells or when cells die, there is DNA that has to either be absorbed and or then re-established within new cells. And there's a framework, there's scaffolding, there is replication and copying that occurs. And all along these pathways, there can be disruption. And what is it that causes this disruption? We can see this accumulation of damage over time throughout our lives. There are listed premature aging syndromes out there that have been studied, and they see that the biggest issue in these syndromes, in these premature aging syndromes, is this DNA damage. We see replication errors, we see the fact of what oxidative stress can do, oxidative damage can do. They can cause mutations and disruption of the repair of areas in the DNA. And then, of course, the thing that we're learning about more and more is methylation, these areas of methylation as we age that either promote genes or turn genes off. And certainly as we get older, we see a lot of particularly tumor suppressive genes go off and therefore increased risk of cancer. We see a lot of genetic changes that have to do with metabolism because of oxidative stress and therefore increased risk of chronic illnesses such as diabetes and Alzheimer's. These all can occur, and it's not only this DNA in the nucleus itself, but in the mitochondria, which is where our energy is produced. So we've seen that, 2 or 3 weeks ago, I talked a little bit about the issues with fructose and its metabolism down into uric acid and what that can do to, as far as oxidative stress, and how that then can be a source of damage to our DNA. Deficiencies in just repair mechanisms are problematic as well. And then not only do we see this genetic instability, but secondarily we see changes in the little end caps of our DNA called telomeres or telomeres. And there's an enzyme that increases the telomere length. One of the best descriptions of what these end caps are is the description that we see when people describe it as the little end caps on, say, a shoelace. And the longer, the better. As cells replicate and over time, there is a number of times that certain cells can replicate and then they just basically die off. based on what happens to this telomere or this little end cap length. The longer, the better. And we see that with not only health, but also lifespan. The longer the telomere, the longer the health, the better the health, and the longer the lifespan. And we can measure that. That's done in testing. We've been able to do that for a long time. So what things can we do to increase this enzyme to keep the telomeres longer on our cells? Well, exercise has been shown to greatly enhance this enzyme that keeps these areas on the DNA longer. We also know that a plant-based diet is very beneficial. So definitely more plants and greenery, green type vegetables are going to be much better as far as managing the end caps of our DNA. Essential fatty acids, omega-3s, are very beneficial, as well as antioxidants, vitamin C, E, vitamin A, and also vitamin D can be very beneficial. Anything that we've talked about, certainly from a lifestyle standpoint, generally in terms of nutrition and exercise, stress reduction, cortisol can be exceedingly detrimental to our DNA in terms of what it can do to create more oxidative stress and more challenges to replication of DNA and telomerase activity. So these are two areas. I know this is kind of nerdy science, but it's really important to know these things because as the exponential growth of information is occurring faster than we can even keep up with it, we are seeing that as we identify these things, we can then begin to target them and work on our overall health, wellness, and as we've talked about time and time again, we want our health span to correlate with lifespan and definitely sort of condense that illness phase of life to the end of life. And while we're here, we want to stay as functional as possible. And we are seeing so many advances and so many ways to try to keep our bodies in great working and functional order. One of the medications or supplements that is most widely used for telomerase activation is a supplement called TA65, and that's been around for several years and has been shown to increase telomere length for folks. So that's one way to do it from another supplement standpoint. But in addition, it still comes down to lifestyle. You can't take that and not do all the other things and expect things to be optimal. So it still all starts with everything we've continued to talk about over the last year and a half, which is, fasting is very beneficial and a plant-based diet is very beneficial. Trying to stay away from processed foods, staying away from high fructose corn syrup, lowering your sugar intake, exercise, managing your stress, all of these things are going to have benefits in terms of allowing us to be that person that people look at and say, I can't believe you're the age you are. You actually look 10, 15 years younger, which is what we'd like to see. And we're also able to do that in our testing in terms of functionality. We are seeing the ability to now look at tests that will tell us what our biologic age is. And we talked a little bit about that a couple of weeks ago. So I'm going to continue over the next 2 or 3 weeks and walk through the rest of the hallmarks of aging. There are 9 of them. We've covered a couple of them today: genetic instability and telomerase and telomere attrition or shortening. So hopefully you've gotten a little bit of an idea and a little taste of these things, but we're going to continue to say the same things over and over again in terms of what it is that truly keeps us functional and delays the onset of chronic illness and issues with decline in function. You all have a great week, and we will talk again next week.